Hello students, so in this lecture we will discuss about some computer memory devices and the first device that we will discuss is it's a thin film. uh, it's called Cryotron. Thin film Cryotron is a storage device. And the role of this device is it diverts current from one superconducting path to another superconducting path. So it diverts current from one superconducting path to another on this, or it provides a persistent current to flow in a superconducting loop. And these are considered to be two different cases. So this is the case one, and this is case two, and there is a switching taking place between these two cases, and this switching is provided by a magnetic field. So right, as there is a switch between the two cases, and this is caused by a magnetic field B, which is from the current produced by the current. So the switching is caused by an inductively coupled current induced by the transition, and it causes a large scale storage associated with the large scale storage in a superconducting computer. And it can replace the magnetic storage devices of the conventional computer. Replace the magnetic storage in conventional computers. The other type of devices, this is the first device, that's number one. The other device for computer storage is called crucial. It's called a TrueCell. Now, this is the first storage device which is inductively coupled type. So, first storage device which is inductively coupled. There is a thin superconducting film which is made up of lead, and there is a small hole of a few millimeters dia. So the shape is something like this. This is the film, and there is a small hole here, and there is a crossbar. It's a crossbar which acts as the switch. So draw it. One bar, two bars like this. And there are current passing through these bars. So this is Ix, this is Iy. So the different states, and this is actually the sense line. You can call it as the sense line, which senses the film. So there are two different states. One, state one is like this. Current is flowing in this direction. These two directions, and magnetic fields are produced like this. This is inductive magnetic field, induction currents. So this, and another state is the opposite one. That's how the current is flowing, and the magnetic lines of force. So this is state 1, and this is state 2, and that is switching taking place these two states. So the current stored in the two D-shaped loops like previously told, these two loops, this is one D-shaped and this is another D-shaped, two D-shaped loops. By each half of the hole and cross by each half of the hole and crossbar, Now the currents either add or subtract. The currents either add or subtract. If now there is critical current. So if the total current if the total current is greater than the critical current, then the crossbar becomes resistive. It causes the crossbar to become resistive, and it will then allow the flow to penetrate through the hole and allow the flow to penetrate through the hole. And induce an sense line on, and it will induce a sense line as told diffusion. So this is how the sense line is introduced. The sense line, and this is considered as the one state. And if the opposite thing happens, if it is less than the critical current, then the different type of so it becomes conductive and it doesn't show a sense. Now, so this the another type of magnetic the computer storage devices is the magnetic multi-layers. And this uh, system is based upon the storage is based upon a domain wall interaction. Now let's take an example. Suppose there is a nickel iron magnetic layer. There is another nickel iron magnetic layer. Here the magnetic lines of force are in this direction, and so this is also nickel Fe, but the magnetic lines of force here are in this direction. And in between we have one silicon oxide, So these walls are also called Neal walls or quasi-Neal walls. Now the Neal walls, they are opposing the rotational sensors. So Neal walls, they are opposing rotational sensors, and directly superposed, providing good flux closure. Providing good flux closure. So it causes the wall energy to go down. The wall energy, it goes down, and it's also called the Neal cross tie transition. And it occurs in thicker films. And, and it is not in a single layer film. A thicker film also, it is a multi-layered thicker layer film. Now, it's always not necessary to have a full Neal wall. And in the second film to provide this closure. So if there are two films, one and two, the Neal wall may be present in the first one. This may not contain the Neal wall, and it is not always possible to have this Neal wall in the second one for the closure. Since a Neal wall in one film can induce a Neal wall in the other, so the reason that a Neal wall in the first one can induce a Neal wall in the other, so the second one may not have the Neal wall from the initial state. So since a Neal wall in one film can induce a quasi-Neal wall, in the other film. So it's not possible, not necessary to have Neal wall in the second one as well. So this is one of the magnetic computer storage devices.